నమస్కారం. డాక్టర్ బిఆర్ అంబేద్కర్ సార్వత్రిక విశ్వవిద్యాలయం విద్యార్థిని విద్యార్థులకు స్వాగతం.
Hello students, today's lesson is on gamma and beta functions. Gamma and beta functions are a part of your UG third year course material on mathematics. Gamma and beta functions play a very important role in the evaluation of Bessel and hypergeometric functions as integrals. In today's lesson, we will define gamma function and also the beta function. We establish a relation between the gamma and beta functions, and also we evaluate some of the integrals based on the gamma and beta functions. First of all, let us define the gamma function. Consider the integral 0 to infinity e power minus t to the power of n minus 1 dt. This is an infinite integral in the sense that its upper limit is infinity, and it is an improper integral in the sense that when n is less than 0, this t will form a singularity. It can be proved that when n is greater than 0, this integral is a convergent integral, and this integral is defined as the gamma function, namely gamma n. So, gamma n is defined as an infinite integral 0 to infinity e to the power of minus t into t to the power of n minus 1 dt for n greater than 0. This integral is also called the Euler's integral. Once you define gamma n, you can also define gamma n plus 1 as integral 0 to infinity e power minus t into t to the power of n dt. This is t to the power of n dt for n greater than minus 1. Once you define gamma n plus 1, you can evaluate it with the by integration by parts. Gamma n plus 1 is equal to integral 0 to infinity e power minus t into t power n. When you integrate it by parts, the first part will be t power n into minus e power minus t between the limits 0 to infinity minus integral 0 to infinity n into t power n minus 1 minus e power minus t dt. The first part, that is the integrated part between the limits 0 and infinity, will be 0, and then the second part is nothing but your n into 0 to infinity e power minus t into t power n minus 1 dt, which is again gamma n. So, gamma n plus 1 is equal to n into gamma n, which is a basic relationship in the gamma functions. This is a recurrence relation. In fact, it can be viewed as a difference equation. So, from this you can also write gamma n is equal to gamma n plus 1 by n. If you take the n other side, gamma n is equal to gamma n plus 1 by n for n greater than minus 1. Now, if you are able to write again repeat the integration by parts on gamma n, you will get gamma n plus 1 as n into n minus 1 into gamma n minus 1, and again if you further repeat it, it is equal to n into n minus 1 n minus 2 into gamma n minus 2 and so on. When n is a natural number, gamma n plus 1 will be equal to n into n minus 1 n minus 2 and so on. The last one is gamma 1 into gamma 1. Now, we have to evaluate what gamma 1 is. Now, gamma n is defined as integral 0 to infinity e power minus t into t power n minus 1 dt for n greater than 0, and when n equal to 1, this integral will reduce to integral 0 to infinity e power minus t dt, that is equal to minus e power minus t, which is equal to 1. Hence, gamma 1 is equal to 1, so that your gamma n plus 1 is equal to n into n minus 1 n minus 2 and so on up to 1, which is equal to n factorial in the usual sense. That is the reason why the gamma n is called a generalized factorial function. Now, you can also extend gamma n's definition for the negative values of n. Even though we are denoting the gamma function by n, here n need not be a natural number, n can be any of the real numbers. Initially, we started with the definition of gamma function with n greater than 0. However, based on this relationship gamma n plus 1 is equal to n gamma n, you can define the, you can extend the values of gamma for negative values of n. Now, for n between minus 1 to 0, n plus 1 is greater than 0. So, that gamma n is equal to gamma n plus 1 n by gamma n plus 1 by n. When n plus 1 is greater than 0, gamma n plus 1 is well defined. So, that gamma n plus 1 by n when minus 1 is less than n less than 0 is defined, well defined, gamma n is well defined. So, you have extended the gamma n, that is the definition of gamma n, to the values between minus 1 to 0. Similarly, you can extend the definition of gamma n, you can extend the definition of gamma n for minus 2 to minus 1 or minus 3 to minus 2, minus between minus 3 to minus 2. For all these values gamma n is well defined. However, when n equal to 0, you cannot define gamma 0, because gamma n is equal to gamma n plus 1 by n. Here there is a 0 in the denominator, hence gamma at 0 is not defined. Similarly, once gamma at 0 is not defined, gamma at minus 1, that is equal to gamma 1 gamma 0 divided by minus 1 is not defined. Hence, your gamma function is well defined for n greater than 0 and also for negative values except at the negative integers, and also at 0 it is not defined. So, in terms of factorials, once you assume that n is a natural number, you can define these gamma n in terms of factorials, and gamma n is defined as n minus 1 factorial, or gamma n plus 1 is defined as n factorial divided by n, n minus 1 factorial is defined as n factorial by n. Based on this, you can evaluate 0 factorial when n equal to 1, n factorial is well defined, n is well defined, n minus 1, that is 0 factorial is taken as 1. And for all negative values, these factorials are undefined in the sense that n factorial will be plus infinity or minus infinity when n is equal to a negative integer. All these things are depicted in the form of a graph in terms of the factorials. This is the graph of factorial n when n is drawn on x axis and n factorial is drawn on y axis. This will be the graph for minus 1 to infinity, and at minus 1 this is going to be infinity. This is like an asymptote. Similarly, between minus 1 to minus 2 the graph will be like this. Similarly, between minus 2 to minus 3. So, it varies between minus infinity to plus infinity at the negative integers. This is the graph of the factorial function n. Now, once you define a gamma function, you can evaluate the gamma function for various values of n. One important aspect is the gamma half. Very frequently you come across the value for gamma half. So, let us evaluate the value for the gamma half. Now, gamma n is defined as integral 0 to infinity e power minus x into x power n minus 1 dx for x greater than 0. Now, I will substitute in place of x like this, x power n is equal to t. So, that n into x power n minus 1 dx will be dt. So, this integral, that is gamma n, will be reduced to 1 by n integral 0 to infinity e power minus t raised to the power of 1 by n dt. And when n equal to half, this will be gamma half, that is equal to integral 2 into, because 1 by n is there, 1 by 2 is 2, 2 into integral 0 to infinity e power minus x square dx. Now, what I will do is I will take gamma half into gamma half, that is gamma half whole square, that is taken as 2 into integral 0 to infinity e power minus x square dx and 2 into e to the power of minus 0 to infinity e power minus y square dy. So, taken together into double integral 0 to infinity 0 to infinity 4 times e power minus x square plus y square into dx dy. Now, we introduce the polar coordinates for the evaluation of such integrals. Polar coordinates are given by x equal to r cos theta, y equal to r sin theta. So, that theta varies from 0 to pi by 2 and r varies from 0 to infinity, and a dx dy of the integral is equal to r dr d theta. It can be easily obtained. Now, based on that, gamma half whole square will be equal to 4 into integral 0 to pi by 2, and within the brackets the inner integral is integral 0 to infinity e power minus r square dr into d theta. It is just like your earlier e power minus x square dx. Again, if you put r square is equal to v, you will get 2r dr is equal to dv. So, the inside integral will be equal to minus e power minus v, where r square is equal to v, between the limits 0 to infinity, and at infinity this is 0 and at 0 this is simply 1. So, that the entire integral will be equal to 2 into integral 0 to pi by 2 d theta, when d theta between the limits 0 to pi by 2 is your pi by 2 multiplied by 2 is equal to pi. So, that your gamma half whole square will be equal to pi, or gamma half is equal to root pi, because gamma half cannot be negative. Even though gamma half whole square is equal to pi, gamma half should be equal to plus or minus root pi. We take only positive values because gamma half cannot be negative. This is presented here, gamma half is equal to root pi, since gamma half is always greater than 0. Now, you can further extend the gamma value for negative values of n, that is when gamma based on the relationship, that is gamma n equal to gamma n plus 1 by n, when n is taken as minus half. So, gamma n plus 1, that is simply minus half plus 1 is gamma half, it is well defined because its value is root pi, divided by minus half is equal to minus 2 into root pi. So, the gamma half, gamma minus half is equal to minus 2 into root pi. Similarly, you can take n equal to minus 3 by 2. So, that gamma minus 3 by 2 is equal to 4/3 root pi, and so on. So, like this you can extend the values of gamma for negative values of n. Now, let us go for the definition of beta function. Now, let us define the beta function as an integral, definite integral, that is between integral 0 to 1 x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 dx for m greater than 0 and n greater than 0. I repeat the definition, beta mn is defined as integral 0 to 1 x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 into dx. Here also m and n need not be natural numbers, they can be any real numbers. Of course, the restriction is m greater than 0, n greater than 0 is there. Now, from this definition of beta function, what I will do is I will simply write x is equal to 1 minus s. I will write x as 1 minus s. So, that x is 1 minus s raised to the power of m minus 1, 1 minus x will be equal to s raised to the power of n minus 1 into ds. Whereas, the integral is in between 0 and 1, because there is 1 minus here, dx is equal to minus ds. The integral will be between 1 and 0, that minus s minus compensates the conversion of integral into again 0 to 1. So, this when compared to the original definition of x to the power of m minus 1, 1 minus x whole to the power of n minus 1, in place of now n you have m, in place of m you have now n. So, that this is equal to your, as per the definition, beta nm. So, your beta mn is equal to beta nm, that means you can interchange the arguments inside the beta function, beta mn is equal to beta nm. Similarly, you can also obtain another form of the beta function. Some books states the definition like this also. If x is taken as sin square theta, in place of x, if you put x is equal to sin square theta, then 1 minus x is equal to cos square theta, 1 minus sin square theta is cos square theta, and then dx is equal to 2 sin theta cos theta, and x as x varies between 0 to 1, theta should vary between 0 to pi by 2. So that the beta mn is equal to x to the power of m minus 1 will become sin to the power of 2 m minus 2 multiplied by cos to the power of 2 n minus 2 multiplied by 2 sin theta cos theta is there, that will compensate for 2 m minus 1 and 2 m minus 1. There will be a 2 here. So that beta mn is equal to integral 0 to 2 into integral 0 to pi by 2 sin to the power of 2 m minus 1 cos to the power of 2 n minus 1 into theta d theta. This is also stated as the definition for the beta function in some books. So, you can interchange these two definitions as and when you require the evaluation in the evaluation of integrals. From this definition you can obtain when n equal to m equal to half and n equal to half, this integral reduces to 2 times integral 0 to pi by 2 d theta, that is equal to pi. That means beta half half is equal to pi. Now, let us establish a relationship between the beta and gamma functions. The relationship between the beta and gamma functions is stated here. Beta mn is equal to gamma m gamma n divided by gamma m plus n, where m is greater than 0 and n is greater than 0. The relationship is once again stated here. Beta mn is equal to gamma m into gamma n divided by gamma m plus n for m greater than 0 and n greater than 0. Now, how to obtain this relationship? I will consider gamma m into gamma n, that is equal to integral 0 to infinity e power minus x into x to the power of m minus 1 dx into integral 0 to infinity e power minus y into y to the power of n minus 1 dy, the gamma m and gamma n definitions. So, both multiplied. What I will do is I will simply substitute x equal to u square here and y equal to v square here. So, that these two integrals, the product of these two integrals will reduce to 4 times integral 0 to infinity and 0 to infinity e power minus of u square plus v square, because e power minus x e power minus y is there. In place of x you have u square, in place of y you have v square. So, e to the power of minus of u square plus v square multiplied by x is now u square raised to the power of m minus 1, and then y is again v square raised to the power of n minus 1 will reduce to u power 2 m minus 1 into v power 2 n minus 1 into du dv. So, once again you introduce the polar coordinates, namely u equal to r cos theta and v equal to r sin theta, so that this integral will reduce to integral 4 times integral 0 to infinity, theta varies between 0 to pi by 2 and r varies between 0 to infinity, e power minus r square, because u square plus v square will be r square, u equal to r cos theta, v equal to r sin theta, u square plus v square will be simply r square. So, e power minus r square into r to the power of 2 m plus 2 n minus 1 multiplied by u is r cos theta, r sin theta, hence cos to the power of 2 m minus 1 into theta, sin to the power of 2 n minus 1 into theta into r dr d theta. This r is absorbed here, or otherwise a 2 must be here. So, that is equal to again written as product of two integrals, namely 2 into integral 0 to infinity e power minus r square r raised to the power of 2 m plus 2 n minus 1 into dr, then into 0 to pi by 2 cos to the power of 2 m minus 1 into theta sin to the power of 2 n minus 1 into theta d theta. The first integral, when you introduce another variable, namely r equal to root t, this will get reduced to integral 0 to infinity e power minus t to the power of m plus n minus 1 into dt. R is substituted as root t. So, this will get reduced to e power minus t into t to the power of m plus n minus 1, and this is again integral 2 to 0 to pi by 2 cos to the power of 2 m minus 1 sin to the power of 2 n minus 1 d theta. You can observe that this is your, as per the definition of gamma function, this is your gamma m plus n. Again this we have shown as the beta mn. In the definition itself we have introduced the polar coordinates, obtained this form, so that gamma m into gamma n is equal to gamma m plus n into beta mn, or you can write beta mn as gamma m gamma n divided by, if you take this to the other side, gamma m by gamma m plus n. This is the relationship between the gamma and beta functions. Now, let us evaluate some of the integrals based on the gamma and beta functions. The first one is, let us prove beta mn as integral 0 to infinity x to the power of n minus 1 divided by 1 plus x whole to the power of m plus n into dx, that is also equal to integral 0 to infinity x to the power of m minus 1 by 1 plus x whole to the power of m plus n dx. Now, beta mn is defined as integral 0 to 1 x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 dx. Now, it is only a matter of change of variable, change the variable x to 1 by 1 plus t, so that dx will be equal to minus of 1 by 1 plus t square 1 by 1 plus t whole square into dt. So that when x tends to 0, t should tend to infinity. Similarly, when x equal to 1, t should be equal to 0. So that you substitute here these variables. So, the resultant integral is equal to minus integral infinity to 0 1 by 1 plus t raised to the power of m minus 1, because x is taken as 1 by 1 plus t, 1 plus t raised to the power of m minus 1, then 1 minus t, 1 minus x is simply 1 minus 1 by 1 plus t raised to the power of n minus 1 into dt by 1 plus t whole square. The minus is absorbed here and writing here as 0 to infinity integral, and then once you reduce this, this entire integral will reduce to t power n minus 1 by 1 plus t raised to the power of m plus n dt. Similarly, when, because beta mn is proved as beta nm, it can be proved that this is also equal to integral 0 to infinity t power n minus 1 m minus 1 divided by 1 plus t whole to the power of m plus n. When m plus n is taken as 1 in this integral, beta mn is equal to integral 0 to infinity x to the power of n minus 1 by 1 plus x whole to the power of m plus n. When m plus n is taken as 1, m should be equal to 1 minus n. So, that beta mn will get reduced to beta n 1 minus n, that is equal to, the relation between beta mn is equal to gamma n divided by gamma m plus n. So, in m plus n is now 1. So, gamma n into gamma 1 minus n, gamma n into gamma 1 minus n divided by gamma m plus n is 1, gamma 1, we know that gamma 1 is 1. So, as per this definition, that is, we have proved that beta mn is equal to, just proved that integral beta mn is equal to integral 0 to infinity x to the power of n minus 1 by 1 plus x whole to the power of m plus n. So, m plus n is taken as 1. So, that this integral will reduce to integral 0 to infinity x to the power of n minus 1 by 1 plus x dx. But we know that this integral, from the complex analysis, we know that this value of this integral is equal to pi divided by sin n pi. This is equal to pi by sin n pi for 0 less than n less than 1. So, your beta n 1 minus n, that is equal to gamma n gamma 1 minus n divided by gamma 1 is 1. So, gamma n into gamma 1 minus n is equal to pi by sin n pi when n lies between 0 and 1. In fact, you can directly obtain gamma half value from this. When n equal to half, this will be gamma half and this will be gamma half whole square, that is equal to pi by sin n pi. When n is equal to half, it is simply sin pi by 2, which is equal to 1, hence is equal to pi. So, that gamma half is root pi. Now, let us evaluate some of the integrals based on the beta and gamma functions. One such integral is integral 0 to pi by 2 root of tan theta d theta. This you can write it as integral 0 to pi by 2 sin to the power of half theta into cos to the power of minus half theta d theta. Now, we have defined beta mn in terms of sine and cosine like this, that is equal to integral 0 to pi by 2 sin to the power of 2 m minus 1 theta into cos to the power of 2 n minus 1 theta d theta. When you compare this integral with this, you will find that this is equal to integral 0 to pi by 2 sin to the power of beta 3 by 4 gamma 1 by 4, because here 2 m minus 1 is equal to half, then 2 n minus 1 is equal to minus half. If you solve this, you will get, in place of m you have now 3 by 4 and in place of n you have 1 by 4, and you know the relationship between the beta and gamma functions. Of course, beta 3 by 4 gamma 1 by 4, the relationship between the beta and gamma functions is beta mn is equal to gamma m gamma n divided by gamma m plus n, so that gamma 3 by 4 into gamma 1 by 4 divided by gamma 3 by 4 plus 1 by 4 is simply 1. So, this is equal to gamma 1. So, the given integral 0 to pi by 2 tan theta d theta is equal to gamma 3 by 4 into gamma 1 by 4. So, gamma 3 by 4 into gamma 1 by 4 can be written as gamma 1 minus 1 by 4 into gamma 1 by 4, but of course the 2 must be here. So, it is equal to half of this. So, half of this into gamma 1 by 4, this I am writing gamma 3 by 4 as gamma 1 by 4. I just want to make use of this earlier result, namely gamma of 1 minus n into gamma n is equal to pi by sin pi. So, based on this result, this should be equal to 1 by 2 into pi divided by sin pi by 4. Sin pi by 4 is 1 by root 2, it goes out. So, that this will be equal to pi divided by root 2. So, the integral 0 to pi by 2 root of tan theta is equal to pi by root 2. So, like this you can evaluate the integrals using beta and gamma functions. So, in this lesson we have defined the gamma function and also the beta function, and also we have established the relationship between the beta and gamma functions as beta mn is equal to gamma m gamma n divided by gamma m plus n for all m greater than 0 n greater than 0.
ఈ మన ఉన్నత విద్యా కార్యక్రమాలపై మీ సందేహాలు, సలహాలు, సూచనలు పంపవలసిన చిరునామా: డైరెక్టర్, ఆడియో విజువల్ ప్రొడక్షన్ అండ్ రీసెర్చ్ సెంటర్, డాక్టర్ బిఆర్ అంబేద్కర్ ఓపెన్ యూనివర్సిటీ, ప్రొఫెసర్ జి రామిరెడ్డి మార్గ్, రోడ్ నంబర్ 46, జూబ్లీ హిల్స్, హైదరాబాద్ 500033.